My name is Kondwani Mithi, a Chaminade teacher that's majoring in mathematics. Here with me is just a presentation in Form 3 mathematics lessons as such. I ask you to be with me. Feel free. Let us be together until at the end of the lessons. Right, without wasting much of our time, let us start the ball rolling. Hereby now I'm going to introduce a new topic. That's now topic 1 according to the syllabus. It's about the quadratic expressions and equations. Right. So now, before we take ourselves through, let us get to know about the aim of this topic. The aim of this topic lies for 1. It's there mainly to help students understand on how they can solve quadratic equations by factor method. And again, to help students understand on how they can solve quadratic equations by computing of the square. Lastly, to help students themselves on how they can solve quadratic equations by the use of formula. With me again, based on these aims, we'll have the following objectives that will last us in the discussion about this topic. 1, we are to describe quadratic expressions. Secondly, factorizing the quadratic expressions. Thirdly, we are there to solve quadratic equations by factor method. Then factorizing perfect squares, completing of the squares. We'll solve quadratic equation by completing of the squares, and then deriving quadratic formula. Then we'll use that quadratic formula to solve the quadratic equations. And at the very last, we are there now going to handle the real life situation type of problems. So we'll be there trying to formulate and solve quadratic equations from the practical problems. Right. So taking objective 1, we need to begin with it. We are here now going to describe that's a quadratic, that's a expressions. Right. As students, we have handled several types of expressions. But here now we are, out of the many examples of the expressions we have handled, there are some which we call them as quadratic expressions. These expressions, which call them as quadratic, are those expressions which are in the form of that is x squared plus bx plus c. I might write that one down. Ax squared plus bx plus c. What does this mean? For example, look at the example that I have it here. I have an expression here, x squared minus 8x plus 16. This is an expression. When I look at this format here, you'll be able to see that this expression, this form, has got letters A, B, and C. These letters A, B, and C, they simply represent the constants. Right. Like say, for example, here, if I compare the two expressions, this format and the one I have it here, you'll be able to see that this A is a coefficient of x, which has got a power 2, and B the coefficient of x, and lastly here is C, which has got no x. So if you can look at this example here, we have it down here, we may be able to tell that, say, the value of A in this expression is the coefficient of x squared. You can see here, it's x squared, there's x squared. What is here is the same as A. So which means what is here, usually, though there's no number written, we always know that here there's a 1. So you may be able to tell that, say, according to this as an example, the value of A is equal to 1 in this example. And this B we see is the coefficient of x. Therefore here, if I have this example, it means the value of what B should be equal to this number here, which is -8. And lastly, when I look at a C, it's just like a letter, which has got no what? A variable x at all. So here again, you find also I've got 16. which is also a number which has got x at O. Then you can take that, say C here is equal to what? 16. Right. And now, additionally, on the same format, let's try to understand. Though we know the meaning of A, B, and C, we should also understand that this quadratic expression does not tolerate that the value of A should be equal to 0. So usually, we always expect the value of A not to be equal to a 0. Right. Why we say so is that this expression in this format here, where we look at ax squared plus bx plus c, this term here is known as a quadratic term. As such, the entire expression is defined by this as a quadratic expression. Right. So if a is equal to 0, then definitely it will be like 0 times x, then this one will not exist. It means the entire expression will no longer be what? A quadratic expression. So this term here always is known as the quadratic term. And the value of a shouldn't be equal to 0. Similarly, for the rest of the two examples here, you'll be able to say that in the second example, 2y squared minus 10y minus 5, you can be able to tell that the value of a here is 2. Value of b here is minus 10. Value of c here is 5. It doesn't mean always that the expression will also be in x. No, it can be in any other variables, like y, like m, etc. So here it follows again, the value of a, according to this one, is negative 1/3. And the value of b here is the coefficient of, let me come back here. The value of a here is the coefficient of a term which has got power 2. So here, a should be equal to positive 1. Only that we have interchanged up the light up. We have not started up by lighting with the quadratic term. The value of b, according to this one, you can see here there's x which has got no power 2. Then you'll be able to tell, the value of b here should be a coefficient of m which has got no power 2. So you take it as negative what? 1/3. And finally, 1 over 36 does not have a variable m. So similarly here it tells that the c is also 1 over 36. Right. By this little explanation, we might here in a position be able to understand what a quadratic expression is all about. So it means our all interactions here in the quadratic expressions equation, we'll be looking at expressions which are of that one form. Right. Now, let's get now into the objective number 2. That's now factorizing quadratic expressions. The expressions which you have understood very well that are in that form. How to factorize such type of expressions like this one, and that one. Right. Right. First, allow me first of all to define this terminology here, factorizing. When we talk of factorizing, it simply means to find the factors. That's all. So here, if we're going to discuss something about factorizing quadratic expressions, it's just a matter of finding the factors of an expression which is quadratic. For example, in real numbers, we're able to multiply maybe 2 numbers or 4 numbers and get a particular number. Say, for example, if I can have 5 multiplied by 4, the answer I get here is 20. Right. From this light up, we're able to tell that if 5 is multiplying by 4, giving us the number 20, it means 5 and 4 are the factors of what? 20. The same it goes when I've got maybe 7 multiplied by 5. The answer I get there is 35. This tells me that these two numbers, 7 times 5, is equal to 35. These numbers are defined as factors of this. So when I write 35 in this format, it means I've written 35 in factor form. So it means when I write again here, 35 is equal to 7 times 5, it means I have factorized 35. I'll write again 20 in the form of 5 times 4. This tells me that to say the 5 times 4 are the factors of 20. It means 20 has been what? Factorized. So if we talk of factorization, that simply means to find the factors. If it is about the number, you are finding the factors of the number, which when you multiply should give you a particular number, like 4 times 5 gives you 20. Right. Now, our discussion does not focus much on the numbers as such. We are here discussing about the expressions. So what we see here, like from the first example here, of 5 times 4 give us 20. The same thing applies in expressions, whereby we can have some expressions also multiplying each other, like say, talk of 3x plus 2. This can multiply by another expression like x minus 3, like that. And at the end of that, we're going to obtain another expression there. So what implies here, that's to say, if I multiply this by that, I get an expression here. That expression, it simply means it has got factors, which are these ones here. Like I multiply 5 times 4, I get a 20. It means 5 times 4 are the factors of what? 20. So let's see what we can have here. Let's first of all rule out each about the numbers and get into the expressions. And let's see what we get out of the two expressions which I'm going to multiply here. Usually this one is known as a binomial. It's another binomial, 2 terms expression. I think we know this by JC course. Right. If I can multiply as I've done 5 times 4, it cannot be different with the way we multiply the expressions here. How we multiply this is a process which in JCE we defined as what? Talk of expansion. So this is as good as just writing 3x plus 2, then x minus 3, like that. So if I'm to multiply the two expressions as I'm doing 5 times 4, here the process will be like every term of the first bracket should multiply the terms in the second bracket. Such like it would be 3x here, multiplied by x minus 3. Then positive 2 here, we multiply by x minus 3. That's what we do. What do we get now? When we multiply, you find that when I get my 3x squared, so let 3x multiplied by x, the answer I'll get from that is 3x squared. And when I multiply 3x multiplied by negative 3, this gives me minus 9x. And when I multiply 2 times x, that one gives me, that is what? Plus 2x. And then 2 times minus 3, this gives me negative 6. If like terms are there, we simplify. And in this case, we have got negative 9x and a positive 2. But here we don't have a term like this one. That is similar to this one. So this one just had to be dropped down like this. So you have got this plus that. Here to get there is negative 7x. And this is minus 6. So let's now look at this one here. You'll find that this one is obtained from the product of this and that. So if you can look this one out here, you find that this is just the quadratic expression that we are talking about here. So from this calculations, it tells us, as I was doing here, 5 times 4 is 20. And I say 5 and 4 are the factors of 20. Then here again, I should also be able to deduce it out to say that 3x plus 2 and that's a talk of x minus 3 are also a factors of 3x squared minus 7x minus 6. So which means if you write this one in this form, it means now you have factorized this one. It tells you that this one is coming from the product of that and that. As we're able to say 4 times 5 to give you a 20, it means these are the factors of 20. Right. But now the question that we have here aloud is C1. What we have here is just like an issue of now trying to know and more maybe to understand on how best I can process out a quadratic expression and come up the factors themselves. For example, I know that this multiplied by this one gives me this. But now my pressure that I'll have it will be like this. Yeah, thus factorize 3x squared, that's a minus 7x minus 6. Right. So it's more like I have an expression here and I'll need to find the factors of which, if you can consider numbers, it's easy to find the factors of them. Right, like for example, I've got a 12, find the factors of 12 as what? 2 multiplied by 6. Or I'll talk of what? That's a 3 times 4. And you can even have 1 times 12. But this one is not easy to predict that way. So we are now going to discuss about it. How can we find the factors of such type of expressions? Right. Right. Here with me are some basic steps which are supposed to be considered each time to arrive at the factors of expressions which are quadratic. The first step is that we need to consider the description of the factors, solve the terms in the expression. One term is a quadratic term, a term with variable x having a power 2, and another term is a constant, a term which looks like having no x, but we know that x is there, it's just x to the power 0, which is the same as 1. So what do we do with the two terms to be considered in the expression? We multiply them. Like here now, we're going to multiply quadratic term by constant term, like this, as our first step in attempt to find the factors of this expression. So here it means we have got 3x squared multiplied by negative 6, and this gives us negative 18x squared. Step number 2 is to find the factors of the product. Like here, I was multiplying this by this to get this. So step number 2 simply means I have to find the factors of negative 18x squared. Right, but here there are some conditions that need to be considered. This term has got several factors, but here the factors that we need are just 2 factors, which when you add, they need to give you the middle term. Here it is negative 7x. This one has got several factors. 2 factors, which you can multiply. Like say, for example, 12 has got 2 and 6, 3 and 4, 1 and 12 itself in pairs. So like here, if we need a factors of 12, that when we add, they have to give us a 7. It means we are going to omit this, we are going to omit this, but we are going to consider 3 and 4, because these are the conditions that we want. Factors of 12 that when we add, they give us what? 7. So here we have 3 plus 4 is 7. So the same here, when you look at the factors of this one, which can give us negative 7x, you find that the factors of which are right. As now you can see, after substituting 9 minus 9x and positive 2x for negative 7x, we now have 4 terms. 1, 2, 3, 4. But the A expression had 3. 1, 2, 3. Now, having done this, we are now going to step number 4, which is grouping the terms. There are 4, which means now you are going to form 2 pairs. The first group will be carrying 3x squared and minus 9x. The other one, it will be 2x and then minus 6. So after grouping, it's more like categorizing the terms into 2 groups. You are lastly now going to factoring the groups themselves. Simply meaning you do just have to find a common factor that goes into the terms of each group. Like here for this group and that group, I need to look for the common factor that gets into 3x squared and negative 9x. the highest common factor, HF. In this case, it is 3x. Then I open the bracket, I'll get 3x divided into 3x squared, and this gives me x. 3x into negative 9x, and this gives me negative 3. Then I'll go to this group again, I'll do the same. Find a common factor that can divide into 2x and negative 6. But now here, when you're finding another factor in the second group, be careful there. That the factor that you choose for the next pair should be the factor such that when you divide, the result should be the same as the what you got in the first instance. Like here, dividing this one, it is that I got x minus 3. So one factor can divide here and there, so that the result should also be x minus 3. So here, the factor that can divide here and there to get x minus 3 is the positive 2. 2 divides here into that set of the 2x, it gives us x. 2 into negative 6, it gives us what? That is negative 3. So it means the appropriate factor here is a 2. Having done this, the last thing that you do now to obtain the factor of this expression are again just identifying what is there now, another common factor now from this expression. It's like here we've got two terms again, but in expression. Like see, this is one expression added with this other expression. You see that here and here, there's a common factor, which is x minus 3. Take it out. So if here there's x minus 3, here there's also x minus 3. So divide this x minus 3 into 3x, open bracket x minus 3. So it'll be like when this one divides here, it'll be like this is cancelled with this. The result will be 3x. So you come here and write 3x like that. Then now, finally, you do the same on this part. This one cancels with this. What's the measure between 2? So here it means the answer is positive 2. So this is what you have. So if we have done this, it means we have factorized 3x squared minus 7x minus 6. So you need to see that these factors are the ones which we are multiplying area to get this. But now if we are there now going to follow all the steps, we are able to at least find those factors, which was just easy to predict as we do with the numbers. Well, for today, let us stop here. Like the next time we meet, we'll discuss on how we can solve quadratic equations by factor method. Thank you very much for listening.